Imagine you are watching history unfold. The launch of Apollo 11 on July 16, 1969. You hear the iconic countdown to blast off, and you see greatness before your very eyes. The rocket that would take the first men in history to the moon. And then you wonder, how could someone have figured this out? How is what I'm seeing before my eyes even possible? Well, let's find out. Let's take a look at how the Apollo 11 rocket launch actually happened. It all starts with a man named Isaac Newton, who proposed 3 revolutionary laws of motion. However, his third law is the main idea behind a rocket launch, as well as the nature of any force. For every action or force in nature, there is an equal and opposite reaction. Let's suppose you are dribbling a basketball. When you push the ball into the ground, the ball will, in theory, bounce off the ground and end up back in your hand. This is because when the ball hits the ground, it absorbs the kinetic energy stored in the ball and then sends it back into the ball in the opposite direction, causing the ball to rise back up to where it started. Now, if we apply this concept to a rocket launch, an engine, in Apollo 11's case, Saturn V, must produce enough exhaust gases at an accurate enough force directly into the ground in order to cause the inverse reaction of the rocket taking off into the air. But that's just the initial launch. The mission of Apollo 11 was to get the first humans on the moon, which would imply leaving Earth's gravitational field and reaching the moon in a lunar module. What actually happened was that the rocket was separated into multiple parts in order to reach a point outside Earth where the spacecraft can orbit around the Earth and perform a maneuver known as translunar injection, or TLI. The goal of TLI is to buy time for astronauts and supervisors back on Earth to perform final checks and put the rocket on the correct trajectory to reach the also orbiting moon. Once on this trajectory, the last part of Saturn V propelled the lunar module into the moon's orbit, but returning home was no easy task. After 21 hours of moon surface exploration, the lunar module reunited with the command module and performed the opposite of TLI, trans-Earth injection, where the astronauts circled around the moon multiple times in order to put the command module on a trajectory back to Earth. When it arrived in Earth's gravitational field, it prepared for the fiery re-entry using the command module's heat-proof bottom, as well as parachutes to safely land in the Pacific Ocean. The first manned mission to the moon was a success.